This video will provide a brief introduction to the Defender RMF filter system. Defender regenerative media filters by Neptune Benson have been delivering outstanding water quality since 2003. When compared to a traditional high-rate sand filter, some of the operational benefits of using Defender RMF include up to 90% water savings, 50% energy savings, 30% chemical savings, 75% space savings, and 95% less particulate. During normal operation, dirty water is pumped into the filter from the bottom, and clean, filtered water comes out the top. Inside the Defender RMF, there are two key components that deliver filtration: perlite media and flexible tube elements. Perlite is a finely ground powder made up of porous volcanic glass. A layer of perlite coating the tube elements is what captures particulates down to 1 micron. The perlite powder is provided in 25-pound bags and is loaded into the filter tank using the vacuum transfer system. The second component of filtration is the flexible tube element design. Inside the Defender RMF, there are hundreds of flexible tube elements that make up a framework for perlite media to adhere to. Each tube element is comprised of a spiral stainless steel core with a mesh sleeve woven around the outside. During filtration, the flowing water causes the perlite to coat the tube elements, creating hundreds of square feet of filtration area to capture particulates. Here is a visual example of tube elements coated with perlite. Clean perlite media typically has a pressure drop of 2 to 3 psi. As the perlite captures contaminants, the pressure differential will begin to increase over time and can be observed using the pressure gauges or on the filter controller display. Once a day, or when the pressure differential reaches 10 psi, the perlite media should be regenerated. We will cover the regeneration process, which includes bumping and pre-coating, and also discuss changing the media a little later in this video. Now we will highlight the key components of a Defender RMF installation. During normal operation, dirty water from the pool flows through a hair and lint strainer, passes through a pre-coat T, continues through the circulation pump and into the bottom of the filter tank. The water passes through the perlite and flexible tube elements as shown earlier in this video, and particulates are captured by the perlite. Clean, filtered water comes out through the top and continues downstream for disinfection and treatment before returning to the pool. Each Defender RMF system typically has a side-mounted electronic control panel called the RMF12. For a standard installation, the RMF12 controls the effluent valve, pre-coat or regen valve, and variable frequency drive controlling the pump. The RMF12 can be configured to control other operations like UV disinfection and heaters. The vacuum transfer system is generally mounted to the side of the tank and used to load perlite into the filter. The health and status of the filter can quickly be observed by noting the pressures on the influent and effluent pressure gauges. The integrated viewing window can be used to visually inspect how well the tube elements are pre-coated. There are usually two manually actuated air vent port locations. One is generally installed at the highest point of the pre-coat loop and the other is connected on top of the filter tank. It is important to identify where these vents are located on each system as they can be used to purge air from the circulation piping. The bump mechanism is located at the very top of the filter tank. This mechanism is used to mechanically raise and lower the tube elements inside the filter while bumping. The tank drain valve is located on the bottom of the filter with a handle extension for easier accessibility. The pre-coat sight glass is located in the pre-coat loop piping and is helpful when determining the status of the pre-coat process. While there are many other site-specific valves and auxiliary equipment installed on each circulation system, this overview covers the most commonly referenced items when operating a Defender RMF system. Now that we have covered the key system components, let's discuss how the Defender RMF system operates. The Defender RMF system is always in one of 4 operating modes: idle, pre-coat, filter, or bump. Let's begin by covering idle mode. Idle mode is when the recirculation pump is off, the pneumatically actuated valves are closed and no water is flowing through the system. For now, just note that every time the Defender RMF is started, it will go through a 10-minute pre-coat cycle. We will cover pre-coating a little later in the video, while discussing the regeneration process. Filter mode is considered typical operation following a pre-coat cycle. The system is filtering and recirculating clean water back to the pool. The pump is running, the effluent valve is open and the pre-coat valve is closed. In filter mode, you can see through the viewing window that the perlite media is evenly coated on the flexible tube elements. Here is an example of what filter mode looks like on the RMF 12 display. Next, we are going to cover regeneration of the perlite media. This two-step process includes first, physically shaking the perlite off the flexible tube elements, called bumping, and then second, recoating the tube elements with the suspended perlite during a pre-coat cycle. During the bump cycle, the flow of water stops. The bump mechanism deflates, lowering the tube sheet to the down position and then reinflates, raising the tube sheet and causing the perlite to go into solution inside the filter tank. Each cycle consists of 10 bumps. Looking through the viewing window, you can see how a bump cycle shakes perlite into suspension. While in suspension, the floating perlite retains the contaminants it trapped during filtration. The pre-coat cycle is the second and final step of the media regeneration process. During the 10-minute pre-coat mode, the pump turns back on, and water is recirculated through the pre-coat loop back to the filter, recoating the flex tubes with perlite. Pre-coating reconfigures the media to capture new contaminants. This condensed time-lapse video of the 10-minute pre-coat cycle shows the perlite moving out of suspension and adhering to the flexible tube elements. While pre-coating, some perlite may be seen at the pre-coat sight glass. As perlite readheres to the flexible tube elements, the water in the pre-coat loop will clear. Let's take a closer look at what happens during the regenerative cycle. The purpose of bumping the filter is to disrupt the perlite coating on the tube elements. Once all the perlite is mixed up and in solution, it then gets reconfigured into a fresh layer during the next pre-coat process. Once pre-coated, it is ready to collect more dirt and debris as the system filters more water. Important to remember, the perlite media is the filter, and the tube elements are simply a framework for that filter media to adhere to. After the pre-coat cycle is completed, the Defender RMF will switch to filter mode by opening the effluent valve, closing the pre-coat valve and begin recirculating clean water back to the pool. The filter is now ready to run for the day or until the pressure differential rises above 10 psi. As the filter is in operation, there are two key indicators that the perlite media is loaded with contaminants and needs to be recharged. The first is when the differential pressure is at 10 psi or greater immediately following a bump cycle, and the second is when the perlite is visibly fouled with debris when looking through the viewing window. This image is an example of large debris visible through the viewing window. The frequency of media changes is directly related to how much load is put on the filter and how often maintenance is performed. Additional information about changing the perlite media can be found in the operation and maintenance manual and will be covered in a separate video. The RMF 12 controller monitors and controls the Defender RMF operation. In the top left of the screen, you can see which of the 4 modes the filter is currently operating in, the status of the system valves and pump, and time remaining for operations such as pre-coating or bumping. In the upper right you can see the current filter pressure differential. To learn more about using the RMF 12 controller, please see our RMF 12 video. We hope you will also take a moment to browse our Defender RMF video catalog to learn more about other topics briefly covered in this Defender RMF introduction. For additional information, please consult the operation and maintenance manual. This can be found on the RMF 12 controller or online by following the QR code shown here.